Hi everybody, we've been continuing our study on properties connected with geometry, and in this context what we will look into is the concept of altitudes of a triangle. Now if I were to draw a triangle, there are a few important concepts you will have to know about a triangle. So to start with, an altitude, if ABC is a triangle, an altitude is nothing but a straight line passing from the vertex perpendicularly to the opposite side. So this is going to be an altitude, and similarly this is going to be an altitude, and this is going to be an altitude. Now you can clearly see that there is a point of intersection. Now this point of intersection is called as the orthocenter. Now there are certain important proofs that you will have to know with regard to the altitude of a triangle. Now before I could go on with that, let me give you this particular information. Say, imagine you have a triangle which has two altitudes given. So this is going to be my A, B, C, and there is an altitude here and an altitude over here. Now this intersection is named as H. Let us assume that this point is H. Now this altitude, which is hitting the side AB, will hit the side at 90 degrees, and similarly let me name it as, say, ABC. Let me take this as E and F. So CF will hit AB such that a 90 degree angle is made. Similarly BE will hit AC such that a 90 degree angle is made. Now if someone is asking you what is angle BHC, what would your answer be? If this happens to be an objective question, they are asking you to find BHC, what would the answer be? The answer is simple. It's going to be 180 degree negative angle A, the angle that is present here. If this angle is theta, suppose if this angle is given to be as theta, then this is going to be 180 degree negative theta. So this is an important information I would like to give when two altitudes are given. Okay, so having given you that side note, number one, let me go up and give you this question. There is a very important question which has been asked in one of the competitive, or I would say Olympiad examination. The question is as follows: suppose the altitudes of a triangle are 10 units, 12 units and 15 units. Find its perimeter. We are asked to find the perimeter of the triangle, that is A positive, B positive, C. This is required, and we also know there is a formula which is given as S is equal to A positive, B positive, C divided by 2. This is using Aaron's formula. This is just to give you an highlight. Now this is the question given. Now we have the following choices. You can pause the video and attempt the question. A, is it 107? B, is it 60 over root 7? C, is it 840? D, cannot be determined. Cannot be determined. So you can pause the video and find the solution for this question. Okay, I hope you have got the solution. Now what I wish to do is, before I could go up in solving this question, I would like to shed some light. Now if ABC is a triangle, and if this HB is the altitude and HC is the altitude and HA is the altitude, we have the following result, which is 1 over HA would be less than 1 over HB, positive 1 over HC. This is a result. Now the question is this result true? Now I'm going to show you this result is true, and in the process you will learn some important deductions which will be applied in solving this question. That is the reason I am actually proving this result, so that you would be able to apply those results in solving this question. So having mentioned that, let me head on. Now in a triangle, if ABC is the triangle, clearly we know the following, right? So this is the proof for the result. Proof to show that 1 over H suffix A is less than 1 over H suffix B, positive 1 over H suffix C. We are going to prove this. Now if we consider triangle ABC, then clearly if this is a triangle, then the sum of the two sides would be greater than the other side, right? Clearly A positive B would be greater than C. This is the check actually that we would use whenever three sides are given. If this check fails, then the sides given cannot form a triangle, right? So we start this in this fashion. We start the proof in this fashion. If we consider triangle ABC, then clearly A positive B is greater than C. Also, let H suffix A, H suffix B, H suffix C be the altitudes of triangle ABC respectively. Now we have got that. Now we already know the area of the triangle, right? We have got a formula. So let me draw the triangle again here. This is A, B, C. If this side is A, this side is B, this side is C, and we got the altitude here. The altitude is H suffix A. Similarly, altitude will be H suffix B, and so on, and H suffix C. Now if I were to find the area, what is the formula of area? Area is nothing but half times base into height, right? So using this information, this is going to be 1 over 2 times. The base is A units and the height is HA, and this is the area. So we got a relationship. So what I wish to do is I would like to take this 2 out to the left. Now before I could take the 2 out to the left, I have obtained this area taking HA to be the height here. Now what if someone were to take the area with HB as the height, right? You can shift this triangle like this, and HB would be the height with base being B, right? So let me state that. Also, we know that A is equal to half times B times HB, and A is equal to half times C times HC. So we know this, right? So no matter how you take, the area of the triangle is going to be equal. So since the area of triangle ABC is the same, this would mean all of these things would be equal. So this means 1 over 2 times A into HA will be equal to 1 over 2 times B into HB is equal to 1 over 2 times C into HC. So I can very well cancel these things, and I have like this: A into HA is equal to B into HB is equal to C into HC. So this is what I have got. Okay, so this is one particular deduction we have obtained. Now let's move on. But apparently what we have here is, just observe this. This can be actually rewritten as 2 times A is equal to A times H suffix A, right? So though we have got this relationship, we also know that, you can write like that, we also know that A times HA is equal to 2A. So A times H suffix A is equal to 2 times A, and similarly B times H suffix B is equal to 2 times A, and C times H suffix C is equal to 2 times A. Now from here I can rewrite H suffix A is equal to 2 times A over A, and H suffix B is equal to 2 times A over B, and H suffix C is equal to 2 times A over C. Right? All I'm doing is just pushing the side down, and this is 2 times A. A is area. Now from here this would mean I can rewrite this. This is H suffix A is equal to this. Now can I not write this as 1 over H suffix A is equal to 1 over 2 times A over A? Is it okay for me to write it like this? Now what I wish to do is I would like to multiply the numerator by A and also the denominator by A. I would like to do it like this. So in this case, what do we have here? A gets cancelled. It's equivalent to multiplying this quantity with 1, and that's not going to impact the quantity. So A can be cancelled. So this is now equal to A over 2 times A. This is my 1 over H suffix A. H suffix A. Also 1 over H suffix B is equal to, I can rewrite the same thing. So this is going to be B over 2 times A, and 1 over H suffix C is equal to C over 2 times A. So this is the relationship that we would be using. Now we also know that, what did we start? Let me show you that. We also know that A positive B is greater than C, right? A positive, if not they wouldn't be a triangle. We know that A positive B is greater than C. So what I would do is I will divide by 2 times A both sides, and that's not going to alter the inequality. Now this can be rewritten as A over 2 times A positive B over 2 times A is greater than C over 2 times A. But what is this? A over 2 times A, 1 over H suffix A positive, what is this? B over 2 times A. B over 2 times A is 1 over H suffix B is greater than, what is this? 1 over H suffix C. So hence we have got this result. Now you might be wondering that what is this? We have asked to be showing this, right? But we have apparently shown this. But upon rearrangement, this will lead us to this. Now the most important part here is over here. H suffix A is equal to 2 times A over A, which can be worded as 2 times area over the side A. So this is what would be used in solving this question, right? So I'm going to show you how to solve this question. Okay, so let's solve this question. We've been given that the altitudes on the ratio of 10, or I should say the altitudes are 10, 12, 15. So what I would like to do is I would like to take them like this. H suffix A is equal to 12, H suffix B is equal to, in fact it's 10. h suffix a is equal to 10, h suffix b is equal to 12, and h suffix c is equal to 15. So if I were to take the ratios, this would mean h suffix a is to h suffix b is to h suffix c is equal to 10 is to 12 is to 15. Fair enough, right? So I'm using the space here to solve the question. Now you know that h suffix a is equal to 2 times a over a. Now if I were to rewrite this, this is going to be a is equal to 2 times capital A over h suffix a, and similarly b is equal to 2 times capital A over h suffix b, and c is equal to 2 times capital A over h suffix c. Now what I wish to do is I would like to take the ratio of a is to b is to c. So therefore a is to b is to c is nothing but 2 times a over h suffix a is to 2 times a over h suffix b is to 2 times a over h suffix c, right? So my 2a gets cancelled, so this is nothing but 1 over h suffix a is to 1 over h suffix b is to 1 over h suffix c. So this is a is to b is to c. But what is HA? HA is actually 10. HB is 12, HC is 15. So this can be rewritten as 1 over 10 is to 1 over 12 is to 1 over 15. Now if I were to simplify this can be rewritten 10 into 12 into 15, we can obtain the LCM, and that LCM would be 60. So 60 times 1 over 10, that's going to be 6, is to 60 times 12, 1 over 12, that's going to be 5, and this is going to be 4. So A is to B is to C is 6 is to 5 is to 4. So this is the ratio in which the sides are. Now therefore if I want to write the side A comma B comma C, I need to take the quantities to be equated to a proportional value. And if I were to take the proportional value to k, so this is going to be 6k, 5k, 4k. So that would be the proportional value here. In the start, I have mentioned to you a formula that S is equal to A plus B plus C divided by 2. This is given by Aron's formula. So this would mean 6 plus 5, that's 11 plus 4, that's going to be 15k. So this is going to be 15k divided by 2 is equal to S. So this is a very important formula that we will have to utilize, because the question wants us to find the perimeter, right? So we have got a relationship that connects the perimeter with S. Of course you have this divisor too, but we can actually utilize that. Now from Aron's formula we know that the area is given by root of S into S minus A into S minus B times S minus C, and I have just obtained the value of S to be as 15 times K over 2. We are going to be utilizing this value over here, and also A comma B comma C we have got it to be as 6k, 5k, 4k. So we will utilize all of this. So this is equal to square root of 15k over 2 times 15k over 2 minus 6k times 15k divided by 2 minus 5k times 15k over 2 negative 4k. So this is equal to root of 15k divided by 2. 6 times 2 is 12. 15k minus 12k, that's going to be 3k divided by 2. 5 2s are 10, this is going to be 5k divided by 2. 4 2s are 8, this is going to be 7k divided by 2. So 2 times 2, 4, 4 times 2 is 8, 8 times 2 is 16. I can take the 4 out, so this is going to be 1 over 4 root of k into k, k squared, and k another k squared, that's going to be k to the power of 4, and 5 3s are 15, 15 into 15 is 225 times 7, 7 5s are 35, 3, 14, 15, 16, 17, 1, 7 to the 14, 15. So you get 1575. In fact, instead of just multiplying all of this, clearly we could have fragmented here itself, because 15, you have 15 here and you got a 15 here. So that would be resulting, when you bring it out of the square root, it will give you a 15 there, and this is going to be k squared, and this 7 would be left alone, so that's going to be root of 7. So this is going to be my area, right? So this is what we have got. Now our idea is to obtain the value of k and then subsequently find out the value of s. That is what is needed at this time. What I will do, I will actually utilize this formula, 2 times a over a. We have already obtained this. I have shown you how to obtain this. Now one of the altitudes is given to be in this fashion, so we can utilize that because we got the area being connected here. Now what I'm going to do is I'm going to rewrite this as a times HA divided by 2 is equal to A, right? That's area. Now my side, let me take this to be a 6K. So 6K, and the altitude, or I would say we've been given the altitudes to be as 10, 12 and 15, right? So if I were to take HA to be as 10 divided by 2, this is the relationship that I've got. Now I will take this relationship and I will utilize it over here. So if I were to take this as 1, therefore I can rewrite 1 to be as 15 divided by 4 times k squared root of 7 is equal to 6 times k times 10 divided by 2. So a k and a k gets cancelled, and 2 will divide here 3 times. This 3 will divide here 5 times. So what have we got? We got k times root of 7. I got a 5 there, and I got a 4 here, and I've got a 10 here. So if you were to cross multiply, therefore k is going to be 4 into 10 divided by 5 into root 7. So 5 divides here 2 times. 2 times 4 is 8 over root 7. So this is my value of k. But we need s, right? So what is the connectivity? You see that? This is the connectivity that we will use. Say, let me take it this as some a dash. So from a dash, we know that, what do we know? S is equal to 15k divided by 2. This would mean s is equal to, substitute the value of k. 15 divided by 2 times k is 8 over root 7. 2 divides here 4 times. 4 times 15 is 60 divided by root 7. So therefore we are expected to find the perimeter, right? So since s is equal to a positive b positive c divided by 2, and we need a positive b positive c, right? So this would mean a positive b positive c is equal to 2 times s. Therefore a positive b positive c is equal to 2 times of s is this value, 60 divided by root 7, which is nothing but 120 divided by root 7,